Sure. Yeah, it's recording. Greetings to the guys at 1306. I'm this side at 4400 today. So yeah, this is where I'll be conducting the session, but you guys you'll also be able to follow, right? So yeah, I see that people are still logging in. So we're just gonna wait for 5 more minutes and then we will begin with the session. Can you please switch off your mics? Can all students switch off their mics? Because if you don't do that, we're gonna be hearing multiple sounds, right? And that will cause a disturbance. Ibo. No, good. Just waiting for 10:40 will be beginning. Just waiting for the rest to join now. Huh? Kanja, is it possible if they can admit themselves?
See, I must mute that side. See, I'm mute there.
Yeah, no, everything is good.
Okay. Why can't we see?
Why can't you see?
There's a window that comes here usually for you to select students to come in.
To admit?
Yeah.
I think we just closed it.
I want to see what they see.
Meeting chat. So this is for now. This is what they're seeing. But like, if I can see here, this is what they'll see. Admit. 83. Where's the lobby people? Yeah. So this is where you accept your people here and stuff.
Okay.
This is where they get. So in the meeting, and then request to join. Let me accept this one. Let me also. Okay. Chat. So.
Somebody's computer to admit for you so that maybe you can ask Sia to do it for you that side.
To admit for me that side. Okay, yeah, I would appreciate that.
But let me test first because when one comes in, somebody please take it.
The guys at 1306 in the chat, can you just confirm for me if you can still hear me? You can just type a simple yes. Oh, thank you, Vuisani. So the guys in 4400, you can hear me when I speak like this, no? Okay, awesome. Sorry? Ado, okay. Okay.
Okay, number one. We are unable to, is unable to multitask for the admitting of students. Let me organize this. Let me organize this window. This thing will be resolved by second screen.
Okay.
But you can look at We just need a second. Give us a second.
Okay. Okay, guys. So in the meantime, let us open our fluid sim. Let us open our fluid sim software. And yeah, whilst we're waiting for guys to join, I want to begin by informing you that the session is being recorded. So anyone who wants to revisit today's session, they can do so. I'll upload the video just like I did with the first session, right? I hope everyone was able to access the recording of the first session. Um, did everybody access it? Were you able to access the first session of the recording? Okay, so how you access it is that you will always be going to what you call. So under your Moodle, let me just go to Moodle and show you where I upload the videos. Okay. So yeah, so if you can go to Moodle and go to your course, automatic control, my courses. So if you can go to automatic control and then you go to practicals, and then under practicals, you'll see, sorry about that, we're just connecting a secondary screen, right? Okay, so if you can, under practicals, if you can scroll down, at the beginning you'll see announcements for practical labs. Those ones are for like the Arduino kits, the Arduino project. And then if you can scroll down, you'll see Electro Pneumatics 2024 labs, right? So there, under that forum, that is where I post announce. That is where I post announcements regarding the lab sessions, the venue, the time, the lab tests, and the recordings, right? So if you can just wait a bit, yeah. So yeah, if you can click into that forum, you'll see all the discussions that I've uploaded so far. So uh, there is your electro-pneumatic session 1 that we did on the 25th of July, right? 2 weeks back, right? So if you can click into that, you will see, what is it? Let me go back. Oh, sorry about that. So it's under Introduction to Electro-Pneumatic session 1, right? So that is where you'll find the first session, right? That we did, right? So yeah, just remind yourself that this is where you get your recordings, right? So without much waste of time, I think we can begin with the session. So yeah, last last week, I mean 2 weeks back, on the first session, we were covering the right. So today we are now gonna be doing exercise 2, right? Which includes some of the things we did and new things that we'll be doing for today. So yeah, I hope everyone has the software on. And let me just also open my software. Okay. Okay. Okay, so for today's exercise, we'll be looking at opening and closing a supply pipe, right? So the learning objectives is that we'll be familiar with the setup and function of a double acting double cylinder, right? The description of the problem goes as follows: numerous pipes have to be opened and moved, in a water treatment system with the help of shut-off valve devices, right? An actuation option for the shut-off valve will be sought out by means of a test setup, right? Um, so description of the process: the gate is opened when a push button is pressed, right? And then, meaning that your gate is opened when your cylinder is extended, right? It's in the front end position, right? Uh, when the push button is released, the gate is once again closed, right? So for this model, uh, or for this diagram, we'll be using a double acting cylinder, right? And then, in the event of a power failure, the cylinder's piston rod should be retracted to the rear end position. So it is important that you focus on these important statements. Statements like retracted to the rear end position. What this statement means, that last portion, is that how your system should work is that once you press your push button, your cylinder should extend, and then once you release your push button, um, release your finger from the push button, your cylinder should retract, right? So let us go to our software and start building, right? And yeah, later on today, I will be sharing the memorandum to each of the exercises, right? I think I haven't done so yet. So if I can just let me just quickly look at the chat, guys. Just want to see what people are saying. Why are we using? Okay, that is the instruction for this exercise. So for this application, we need to be using a double acting cylinder. I hope I answered you, Vuisani. So for this particular application, we're using a double acting cylinder, right? Um, okay. So let us click on new at the top left corner, and then let us extend our drawing page like this, and then let us start putting in our supply elements. Remember, you always have to be using a compressor, right? And from the first session, we went into detail about the function of our compressor, and we even I even showed you guys the component photo, right? But like, yeah, for those that still want to see what a compressor looks like, you can just click on it on the component, and then click on component photo, and then you'll see how your compressor looks. So I won't do this for every component because we did this in the first session. So just know that if you want to see how your component photo looks like, you just click on the component, and then you right click, and then you select component photo, right? So we will be connecting our cylinder to our air service unit, right? So and then we will have and then we will have so since it's a double acting cylinder, the component that is the valve, the kind of valve that you're supposed to be using, it's a 5 two-way valve, right? So we'll have to go to our valves. Oh, um, let us first put on our double acting cylinder, and then let us go to our valve groups. It's valves. Wait, wait. Oh, so it's under valves. You'll go to frequently used wave valves, and then we'll go for solenoid operated, right? So because it's electro pneumatics, we'll always be using solenoid operated valves, right? So let us put a normally closed 5-way solenoid valve, right? So it's the fourth component in your list under your components there. Okay, so we'll put that on, and then we'll now connect our pneumatic circuit, right? As such, and then like that we're done with like our pneumatics section, right? Now we have to draw the electric circuit that will be controlling our pneumatic components, right? So how you do that is by first putting on your power supply, as I'm doing now. Let us just rotate this one anti-clockwise by 180 so that we can establish a connection. And then we put on a 24-volt line supply, power supply. And then we also rotate that by 180, right? And then let us just connect 24 to 24 and make it straighter there. And then connect 0 to 0 and then make it straighter there, right? So going back to our exercise, let us go back so that we keep track if we are answering the question or not, right? So they're saying the gate is opened when a push button is pressed, right? Um, when the push button is released, the gate is once again closed. A double acting cylinder will be used, of which we have already put onto our workspace. And then in the event of a power failure, the cylinder's piston rod should be retracted to the rear end position. Now, for this case, we are using direct actuation. It was not stated, but we'll just assume that it's direct actuation, right? So, so how you draw your electric circuit is that we'll now introduce a push button, right? So you'll go to switches. On your component library, you'll go to switches, and then you'll go to manually operated, and then you'll go to push button make, right? Um, am I too fast? Yo, guys, I thought I'm speaking slow motion now. Okay, so where did you lose me, guys? Where did I lose you actually? Huh? Sorry? The electrical side, the electric circuit. I mean, okay, let me see. Okay, okay, that other guy is still connecting the pneumatic circuit. Okay, how many are still on the pneumatic circuit? Huh? You're still connecting. Okay, guys. I'm gonna give you 2 minutes to connect your pneumatic circuit, and then we'll go ahead and connect the electric circuit. So just a recap on our pneumatic circuit, we put on a compressor, an air service unit, right? And then because for this purpose, the exercise wants us using a double acting cylinder. Um, we will be using a 5-way valve, right? Now, if you might recall, uh, how do we see that this is a double acting cylinder? First of all, it doesn't have a spring return, right? And it has two ports, so two inlet ports. So this one that I'm hovering over is where your air will be going into to extend the cylinder, and then this one, it's the port whereby the air is it's recycled so that it can retract your cylinder to the rear end position, right? The guys at 1306, have you
Sorry,
connected?
sir, can I ask something?
Okay, sure. Go
Sure,
ahead.
like when it comes to the test, we're gonna given like this. I'm asking, say, if like when it comes to the test, we're gonna given something like this, the description of the problem and also the description of the process, and
Yes,
then
you're gonna.
you have to know how to connect all those things.
Yes, definitely, and you'll also be given the components that you need to build your circuit. You won't be given all, but most of them. But some you'll have to figure
Oh,
out on your own how to successfully answer the question.
okay, okay,
So yeah, the
okay.
guys in here, the guy.
Let's say
Yes,
okay. Let's say we're given the statement and we also all know the components, but the problem when it comes out, like you don't know how to connect them, so you lose marks when it comes to that.
absolutely. You're losing marks if you can't connect. You're losing marks.
Okay, okay. Thank you, sir.
Oh, you're welcome. You're welcome. The guys in here, the guy in 1306 was asking about how you'll be tested, right? So how you'll be tested during a test, you'll be given a description of the problem, and then you'll be given the description of the process, the parameters, the components that you need to use, right? But I won't give you all the components. Some of them you have to figure them out through the statement, right? So yeah, that's what they were asking about that side. So, are you guys fine with connecting the pneumatic circuit? Okay, I think silence means you're fine, right? Okay, so let us continue. So, um, we have to control our pneumatic circuit via a signal, an electronic signal, right? So, how you establish that connection is by first putting on your power supply, as I have done. So yeah, let's I'm gonna give you an opportunity for you guys to also put those power supply. So you're gonna have to put your 24 volts power supply and your 0 volts power supply, right? So if you can put that on. So I'm just gonna maybe delete and then just uh, do it with you guys, right? So you'll have your 24 volts there and then your 0 volts there, right? And your components, you can copy and paste them. You can duplicate them. So you can copy, Control C, and then Control V. And then there's your 0 volt. And then you just need to rotate it 180 degrees so that you can be able to establish a connection, right? So connect this one to this one, 0 to 0. And then we can also copy this, copy and paste. And then, okay, okay. So yeah, we're gonna connect our 24 to 24 as such. Connect. Okay, so we have our power supply on, right? So to allow air to go to the cylinder, we have to have a push button, and we have to what you call have uh, a solenoid valve. So the purpose, let me put on a solenoid valve. Okay, so for starters, what I have put here is your push button, right? So it's the first component under the manually operated switches, right? So you have your push button, and guys, uh, let us agree on one thing. I would like for us to name our components, right? This enables for readability, and it just makes uh, it makes it easy for you to follow your work, right? So let's get in the habit of naming our components. Not all of them, but like the ones that I'm naming, also get in the habit of naming them, right? So for this case, our push button make we'll label it as PB. So that just means push button, and then you can click OK, right? And then there you have your PB. So we'll have, so for this scenario, we, we were not told um, that we have to make a direct actuation or indirect actuation. So we're just going to assume that it's a direct actuation. So a direct actuation means that your push button is connected directly to your solenoid valve. Now let us put a solenoid valve so that you can see it. So under relays, if you can go to under electrical controls and go to relays, you'll find it there, the last component, valve solenoid. So that's your valve solenoid on there, right? So the main purpose of your valve solenoid is basically to establish a communication between your 5-2-way valve, so that it can now open the ports to the cylinder so that you can get actuation. Yes. Assistance for? Or do you have a computer aside? You need a computer. Hmm? Oh, okay. Can you talk to me, Nyarde? Sorry about that, guys. So yeah, our valve solenoid helps us in establishing a communication between our 5-2-way valve, right? So once we push our push button, the valve solenoid will tell the 5-2-way valve on the pneumatic circuit that open and give open and allow air to flow to our cylinder, right? So you have to define your valve solenoid. How you do that is you double click on your valve solenoid, and then you can label it Q0, right? And then you can click OK. Uh, Normally we mean when we say Q0, it's just like another way of saying output in a way. So yeah, this is our output component. We just name it Q0. You can name it uh, VS for valve solenoid. Yeah, you're not really limited, but yeah, I think it's good if we stick to naming our outputs as Q0, Q1, Q2, and etc. Right? So we'll click OK, and then you'll go to your 5-2-way valve solenoid, 5-2-way valve, I mean, and then at the beginning of your component, you will hover over like that small circle in the beginning there of your component, and then you'll double click, right? And then you'll also label it Q0, and then you would have established connection between your valve solenoid and your 5-2-way valve, right? So let us get to the connection. Yes, where did I lose people? Did I lose people? Okay, so mm, so yeah, we are basically now establishing a connection, right? So let's connect our 3 to the 24 power supply, and then connect your 4 to this end of your valve solenoid, and then connect this end of your solenoid to your 0 volts. So let me just make it a bit neater. So like that, we have established our electric circuit, and then this is what you call direct actuation, right? It's important that you know. So for this semester, we'll be going through direct actuation and indirect actuation. So it's important that you know how to differentiate between the two, right? So we are done with our electric circuit and we are done with our pneumatic circuit, and then we can now begin running our simulation, right? So we'll click play. We'll click the play there. And then what you can observe on the pneumatic circuit is that there's a dark blue color going through up until your cylinder. That just means that it's air that is keeping your cylinder at the rear end position, right? But once we're gonna press our push button, the air will recycle and go to the other side, where you see a light blue color, where it will push forward your cylinder, right? Right. The you just raise your hands and then someone will come to assist you guys. Nah? Yeah. Okay. So to the guys at 1306, if you are stuck or you're left behind, just raise your hand and you will be assisted by Sia, nah? So that you do not lose track of where we are. All right, and don't be shy to ask questions in the chat, right? Once I'm done with my explanation, I'll attend to your question. Okay, so we are about to run our simulation. So we click play. Okay, we have already clicked play, right? So as I was saying, once we press our push button, our cylinder will extend, meaning that it will open up the flap in your pipe to allow the whatever liquid to flow. For our exercise, going back to our exercise, they were saying, so this is opening and closing a supply pipe. So whatever this pipe is supplying, once you press your push button, a flap will open. Once the cylinder is extended, the flap will open, allowing the whatever liquid to pass through the pipe, right? So let us see if we have been doing the right things. So if I can press the push button, it should extend, and then if I release, it should go back, right? So let me press. So if it was quick, right? That was because I pressed and then I released. But let me just do it in slow motion, right? Um, so if you press and if you hold, that is when you are allowing supply to go through your pipe. And then should you release, that's when your cylinder goes back to the rear end position, right? Or to its initial position. And then you have successfully answered your question 2, right? So any questions? Any questions? Otherwise, in the absence of questions, I'll be moving on to the next exercise, right? So yeah, but bear in mind that because we've lost some time, we'll be moving relatively faster, but we will accommodate everyone, right? So yeah, let me see. Sure. Huh? Oh, okay. A student is asking about the okay. When I press the push button, you see a red color, right? That red color just means that is the electrical signal uh, uh, going through to be able to actuate your system. So it's the electricity basically passing through. Yours is different. Let me just check. Okay, 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 okay. So yeah, all right. So guys, moving on, let us go to exercise 3, right? Let me close this, then go to exercise 3. Okay, so for this exercise, it's this exercise, it's sealing of cans, right? So there on the right we have your animation of the process, and then yeah, just appreciate that, and let us read the learning objectives, right? So for this setup, for this objective, you'll be familiar with the setup and function of a relay, right? You'll be able to make use of indirect electrical actuation, right? Um, so yeah, keep that in mind that now it's indirect electrical actuation, right? So the description of the problem goes as follows. Half liter cans are filled with wall or ceiling paint at a manual workstation. The lids are press fitted with a pneumatic press, right? So at the top of your press, you are having your pneumatic system there, and then the cylinder is responsible for the pressing, right, of your lid, right? So description of the process: the cans are manually inserted into the press. So your operator comes and then inserts the can into the system, right, preparing it to be closed, right? So after pressing a push button, the the press the press cylinder is advanced. That is, it goes to the front end position. So we have the rear end position, meaning the back position, and the front end position, or the extended position, right? And the lid is press fitted. When the push button is released, the cylinder is retracted to its initial position, right? The sealed cans are removed manually, and a double acting cylinder will be used. So you do not just use any cylinder that you wish to use. You follow the instruction, right? Uh, control control of the cylinder will be executed indirectly by means of a of a push button, right? So I want us to go through an important component, that is the relay, right? And what it is about. So a relay is an electromagnetically actuated switch. So when voltage is applied to the relay, an electromagnetic field is generated. This causes the movable armature to move towards the core, right? Um, the armature acts upon the switch contacts, which are either closed or opened, depending on the design. If the flow of current through the coil is interrupted, a spring returns the armature to its initial position, right? So a relay coil can be used to switch one or more contacts, depending upon the required function. Relays with normally closed or normally opened changeover contacts are used. Um, Let me just give a more clearer picture, right, of all that was said. So you use a relay when you want to um, connect a circuit that uses a high voltage. So a relay uses a low voltage signal to what's this, to bring about to switch on a high voltage circuit. An example might be when you are switching on a motor, right? Motors generally they require a high voltage, right? But you cannot directly put a switch onto the motor. Why? Because there's high voltage around that environment, and you can be electrocuted. To put it harshly, you will go to the hospital, and I don't know if you'll be alive or dead by then, right? So it is important to use relay for such instances, right? Um, just to reduce bodily harm and to be able to control high voltage circuits with a low voltage signal, right? That is why even your switches, the switches that you use to switch on your light bulbs, they use a relatively low voltage. Otherwise, if like they were connected to a bulb that needed a high voltage supply, yeah, you would be electrocuted, right? So basically, that is the main or important purpose of a relay, right? So yeah, and and yeah, that's I think you can now start understanding why we say indirect actuation. So direct actuation is your switch interacting with your component, but like indirect actuation, it's your switch having to communicate with your relay, and your relay having to communicate with your component. So your relay is your middleman in a way, right? So yeah, if we can continue, okay, we won't need that information, right? So yeah, let us get to the building of our circuit. So because some of the components we use them always, like your compressor and your air service unit, no need to remove that, right? And let me just go back again to the problem. So, okay, we are also still going to be using your double acting cylinder. So do not delete that component as well, right? So yeah, so control of the cylinder will be executed indirectly by means of a push button. Okay, so I can say, let me just go out of simulation.
Okay, sorry, sir, to disturb you. Sorry, sir.
No problem, no problem.
We're coming to this. Okay, this one. I'm looking at the description of the process. Ne? We are
Yep.
given all the steps, but then we are not sure. Like coming to the test, we are not sure how we're gonna connect them. Can you please like go step by step and tell when I connect this, it's because of this and this and this, and the statement says this and this, so that we can get more clarification.
Um, let me put it
Okay.
this way. Let me put it this way. Uh, that way would be me leading you directly to the answer, and then the purpose of a test would be meaningless, right? What I will do also is gonna be I'll be putting a description of the component list that you need in order to connect your circuit, right? So I cannot like give you a statement that like tells you all the steps you need to connect your circuit, right? So that would be me giving you the answer. And yeah, that is not a test, right? A test should test your understanding and so on, right? So yeah, I don't know if I've answered you.
Oh, sorry,
Okay,
sir.
okay, fine, sir.
Sure.
Uh, sorry, sir. Uh,
Yes.
can you please go back to the fluid sim, the
All right.
exercise 2?
Exercise 2.
Yes.
Okay. Sure.
Can you please run the simulation?
Let me run the simulation. Okay. So if I press the push button, your cylinder will extend, and then
Oh,
it'll only go back up until you release your finger from the push button.
all right. Or what might be the problem? You see, when you're running the simulation in the circuit, it indicates the red line from
Mm,
24 volts to zero,
mm.
like that, like C that is facing in the opposite direction.
Yeah.
See, when I'm running mine, it's not showing like this. Mine is in the opposite direction.
There is no problem.
Mm.
Let me show you in this way. You can even do this. Even if I would delete this side, right? This side and delete this side, and then let me just delete this node. It'll just run all the same, right? If I can press, it'll extend, and then it'll go back. I can say that you do not necessarily need to have those two 24 volts and those 24 volts, um, but we just make it so that we can have more space to work, right? Because if you as you continue, you'll get to see that we need two 24 volts and two 0 volts so that we can accommodate more components. You understand?
Yes, sir. Okay,
Yeah,
thank
so
you.
yeah, sure. So let me just undo. Okay, so let me just put my power supply back on, right? Rotate 180. So yeah, you don't. So also for this exercise 3, you don't have to delete your power supply. So you don't have to start over. Otherwise, it will be a waste of time, right? So now I'm just connecting back how my switch was, right? Okay, so I'm just gonna delete this line between the push button and the solenoid, and then also delete this line between the solenoid and the 0 volt power supply line, right? And then I'm just gonna put our solenoid there. So we do not have to reconfigure our pneumatic component. It is fine like that. But now what's different is that we will actuate our cylinder indirectly, right? So how that happens is that now your push button is linked to your relay, right? We spoke about our relay, right? Our friend the relay, right? So go to relays group, and then it's the first component under the relays, right? Under your electrical components, right? And then you put it onto your workspace. Just a small tip so that you don't like mess up your library. It's good to always close your library once you get the component that you need, right? Like that. So we'll connect our push button to our relay. That is how our relay looks like. Let me see if we can get a component photo. So yeah, that is the photo of our relay board, right? That's a relay board there. But yeah, you can say a relay as well. And then yeah, we have those that component in the lab. You are welcome to come interact with that, right? Yeah. So we'll connect our push button to our relay as such. So your 4 to A1, and then your A2 to that node there, right? And then we'll name our relay R1 as such, right? And then we'll click OK. And then remember, you always need your valve solenoid to communicate with your 5-2-way valve, right? So you will need to connect that valve solenoid to your changeover, right? So your relay has a changeover component, right? So, but like on a simulation platform, how you show that changeover, it's if you go to switches and then you go to general switches, and then under general switches, you'll see the last component there, changeover switch, right? And then we can also get the description, right? Sorry about that. Let me put it. So general changeover switch, that is tailored according to the component that actuates it, right? For example, if the changeover switch is linked via a label to a switch on delay, delayed relay, the changeover switch changes to a switch on delayed changeover switch in the circuit diagram, right? So yeah, just know that when you are performing indirect actuation, your valve solenoid will be connected to your changeover, right? And then let us also establish a connection between that, right? So your 4 will be connected to your 24 volts, and then will not connect up to anything, right? And then our Q0 will be connected to the 0 volt power supply line, like that, right? And then you would have established indirect actuation. So if you can recall, in our exercise 2 or previous exercise, it was your push button connected directly to your solenoid, and then in turn it was able to perform the function that was requested, right? But in this regard, because it's indirect actuation, now instead of connecting your push buttons directly to the valve solenoid, you connect your push button to your relay, and then via your changeover via your output, your valve solenoid Q0, right? And then we should what should happen is that when you press the push button, your cylinder should extend, and then once you release your finger from the push button, your cylinder should go back to its initial position, right? So to make it a bit more realistic on the software, I'm just gonna rotate our cylinder so that it can be in a downward looking direction, just like the problem, right? So yeah, don't be alarmed, because in our problem, our cylinder is facing downward, right? So I'm just gonna rotate it 270 degrees like that, and just connect like that. I hope that is not confusing. I just want us to make it as realistic as possible when we are running our simulation, right? So we're done with our connections, and then we're gonna run our simulation, right? You're gonna click play, and then you're gonna click the push button. We're gonna press our push button. Okay, so as you can see, our 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 simulation is not running. What is the problem, right? The problem is that as I said, within your relay, you have a changeover. And then, but in this regard, our changeover, like you have a component that is a changeover in the simulation software, right? But we didn't establish a communication between our relay and our changeover. So how you do that is by double clicking on your changeover as such. And I want you to note something, right? So they're saying under label there, corresponding component of electrical circuit. So there you have your relay, and then you have this other component here, right? Which we will not discuss, right? So you have your relay. So what that means is that in order to what that means is that your changeover communicates with your relay, right? So since we named our relay R1, our changeover, we should also name it R1, right? And then we click OK, right? And then now, if we run our simulation, it will run accordingly, right? So once we press our push button, our cylinder will extend, closing our lid, right? And then once the lid is closed, the operator will release their finger from the switch, right? And then the cylinder will go back to its initial position. So let us run that. Let us press our push button. So as you can see, our cylinder is going downward, meaning it's pressing the lid and the can, and then closing the whole product, right? Closing the lid, right? And then if you release your finger from there, you'll see your cylinder going back, right? And then you have successfully connected your circuits, right? And answered the question, right? So, any questions? Otherwise, I'll be. Oh, someone in the chat say it is not working. In here is your simulation working? Awesome, awesome, awesome. Let me just answer the guys at 1306. So let me just view this. Oh yes, I think I answered that question. So for the person that posted that picture, the reason why your model is not running, your simulation is not running, is because you did not create a communication between your relay and your changeover. I can see that you assigned a label to your relay as R1. You need to do the same for your changeover and call it an R1 as well, and then your simulation will run. Oh, they managed to fix it. So are we always going to use sinusoidal? Okay, I don't know about sinusoidal, but I think you mean 5-2-way valve, right? Solenoid operated, only in fluid simulation. So to answer, okay, so this person is asking, say, are we always going to use 5-2-way valves only in fluid simulations? I don't really, I don't think I fully understand you, but let me answer it like this. You'll maybe clarify. So for our case, right? For our sessions, we'll be focusing on 5-2-way valves and 3-2-way valves. Normally, your 5-2-way valves, they communicate with your double acting cylinder, right? They are compatible with your double acting cylinder. But when coming to your 3-2-way valve, either normally closed or normally opened, they communicate to your single acting cylinder. So remember, your single acting cylinder has one port, and normally your 3-2-way valves have one port as well. Whereas your 5-2-way valves, they have two ports, and your double acting cylinder has two ports, right? So yeah, that's how I can answer you. Someone is saying, say mine is doing the opposite. Are you still having the same problem? Because you sent the message 4 minutes ago. Oh, okay. If it's doing the opposite, okay, if it's doing the opposite, it might be because you are not using the correct valve, right? For this case, we're using a normally closed valve. If you're saying it's doing the opposite, that means that immediately when you press play on your simulation, your cylinder is extending. Is that what you are experiencing?
Yes.
Okay, that's because you are using a normally opened valve, right? So the function of a normally opened valve is that immediately when we click simulation, when we click play on the simulation, that valve is automatically allowing air to pass through to your cylinder. But because we used a normally closed, what we're saying is that only open the valve when we instruct you to open the valve, and then you'll be able to get the your circuit running successfully, like we are running it, right? So just check your what's this? Just check the type of valve that you used. Look at the arrows carefully, and then double check. And the valve that we used, it has a spring return, right? That's why when we release our push button, the cylinder is able to go back to its initial position. So the person that is experiencing that problem, were you able to sort it out? And yeah, if you are sitting to someone who was able to successfully connect their circuit, can you help the person? I'm referring to the guys in 1306. So someone is saying, I'm using the same value as you. So yeah, so let me see. So you're using the same valve. You're saying the cylinder is not moving. Okay, so just follow our circuit. Like, is your circuit the same as ours there? Because I think okay, I think uh okay. Okay, on your 5 two-way valve, did you define it? Did you define it as Q0, the same as your valve solenoid? Yes or no? Yes. And then your relay, you are saying that you called it R1, and then your changeover, you also called it R1. Yes or no? Sia, can you help out that side? Can you check? Okay. I was asking that did you define, like, your relay, since you defined it R1, did you also define your changeover as R1? No. Okay. So that is the problem there. That is why you're not your cylinder is not moving. So if you can do that, you'll be able to get your cylinder moving, right? Guys, in your discussions, can you be a bit quiet? Uh, Vuisani, were you able to fix the problem? Okay, it is moving. Okay, we are sorted, né? All right, fantastic, fantastic, fantastic. So we can now move on to exercise 4, right? Okay, so going to exercise 4, let me open up exercise 4. I'm gonna just close this one and go to exercise 4. Exercise 4. Okay, so exercise 4 goes as follows, right? Filling plastic pellets. So the learning objectives is that you'll be able to set up indirect actuation, and then you'll be familiar with logic operations, right? That is another important section, right? So you'll be able to select solenoid valves based on the specified requirements. So the description of the problem goes as follows. Plastic pellets need to be filled from a storage silo, right? If you can see my cursor, that container there, that animation looking like a container, that is your silo, right? And within it, it has the plastic pellets, right? So the plastic pellets need to be filled from a storage silo, and the silo is opened and closed with a flap, right? The process will be started from 2 locations, right? Okay, so I'm glad they mentioned 2 locations. Now, remember, I remember we are using indirect actuation, and with indirect actuation, it involves using a relay. So when they say 2 locations, they're meaning that there's a person in the control room upstairs or like at a distance, and then you have your silo, right? So that's what they really mean by 2 locations. So your relay helps you to work remotely, right? To work from a long distance, right? So yeah, that's what they mean by the process will be started from 2 locations. Okay, and then going to the next slide, it's a continuation. So the flap is opened by pressing either one of 2 push buttons, right? One, and the bulk material is emptied out of the container. When the push button is released, the flap is closed, right? So that to discontinue any flow of your plastic pellets, right? So a single acting cylinder will be used, right? So control of the cylinder will be executed indirectly and by means of a push button. In the event of an electrical power failure, the cylinder's piston rod should be advanced to the forward end position. Great. So for this case, that last statement is very important. What that statement means, I wish I could like do a mini drawing of like what that means, but okay, I'll just try to just explain it. Okay, let me maybe just create a slide and try to draw something, right, to explain what's really happening in this section. Slides. Let me just put slightly out. Hey, why is it in a language that I don't understand now? Anyway, it's not a train smash. So let me just say, I hope it types in English. Okay, drawing. Okay, sketch, 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 sketch of drawing. So just to give an explanation so that you can maybe imagine it of before I draw of how this problem is going to play out, is that they're saying that like you are having pellets and then they're going through your pipe, right? But envision your cylinder in a downward position and already extended, right? So how will the pellets go through if it retracts, right? So this is like kind of opposite to what we're doing previously. So initially, when you press play, your cylinder should be extended already, meaning that we'll now be using a normally opened valve, right? So let me just quickly draw it. Draw. Let me see. Okay, yeah, I can draw. I can use that. Let me just yeah. So what happens is that, say this is your pipe, right? This is your pipe. Say this is your pipe, and then say you are having a cylinder like that. Now, what the the description, what this means, the description of this problem is that your cylinder is already extended, né? But like we want to, when we press our push button, let's just draw a box. This is our push button, and let's say I'm in the top floor there, and then here it's your plant, right? Now I'm in the office there, sitting comfortably, controlling the whole process, right? So So what this problem is saying, say that I press the push button where I am. What should happen is that, and then let me just draw the pellets. So the plastic pellets are circular, right? Let's say our pellets are circular like that. From the silo, right? The silo is something like that, right? The silo has all these pellets and then they're going through this pipe. Now, because our cylinder is already extended, the pellets can't pass through. So how will they pass through? It's when the cylinder is retracted. Initially, it's advanced. So previously, in the previous exercises, the cylinder was in its retracted position, but in this case, it's in its extended position via a normally opened valve, right? So once we press our push button, what should happen is that I'm just gonna draw like dotted lines now. What should happen is that now the cylinder should be at this position now, meaning allowing the pellets to flow, right? So I think with that description, yeah, you'll be able to understand the whole process, right? So going to our fluid sim, we'll just delete some components, not all of them. Your compressor, your air service unit will remain on your workspace, but we're gonna delete our 5-2-way, and then we're gonna delete our cylinder, right? So for now, we are building our pneumatic circuit, right? So how that goes, let me just close these for now. So you'll go to your actuators, and then you'll select a single acting cylinder, right? As such, right? And then for our case, we'll be using a normally opened 3-2-way valve. So I'm gonna just put a normally opened and a normally closed so that you can see the difference, right? So it's a normally, so this one that I've selected that has been selected in gray, it's a normally opened. So the function of the normally opened 3-2-way is to automatically allow air to pass through this valve. But the one on the left is your normally closed, right? The normally closed, it waits for you to generate a signal so that it can allow air to go to your cylinder, right? So that is the difference between the two. And if you can observe something on this one, on the normally opened, there's an arrow that is facing upward on that number 2 port, right? So it just tells you that automatically once you connect me, I'm gonna I'm gonna extend the cylinder. That is what our normally opened works. Our normally open 3-2-way works. So I'm just gonna delete our normally closed valve, and then we're gonna establish a connection like that. Connect our S-service unit to port number 1 or our inlet port, and then connect our outlet port or port number 2 to the inlet port of this single acting cylinder, right? Now, like this, you have already so how we have connected it, we've done it successfully. But I want to introduce something, right? As you've been observing, when we press play, our cylinder opens quickly and closes quickly, right? So for this case, we want our cylinder opening slowly, right? How you do that? You do it by the use of so if you can go to under shut-off valves and flow control valves, you will see a one-way flow control valve. So it's the first component under shut-off valves and flow control valves. So we want once you press our push button, we want our flap or the gate opening in a slow motion. We don't want it opening quickly, right? Just for control sake, so that we can regulate. So that we can regulate the speed at which it opens up, right? So we have a one-way flow. So
A one-way flow, let me just see if we can get a component photo. So this is how your one-way flow control valve works, right? So its general purpose is to control the rate at which the air is coming from your compressor, right? So yeah, and then if we can also go to the component description. Um, Component description. So the one-way flow control valve is made up of a throttle valve and a check valve. The check valve stops the flow from passing in a certain direction, and then the flow then passes through the throttle valve, right? The cross-section of the throttle is adjustable via a regular screw in the opposite direction. Okay, in the opposite direction, the flow can pass through the check valve. So your one-way flow, if I can show the picture again, your one-way flow, if you can see there at the top, it has a knob, some sort of a knob. So that knob, you can calibrate it to however measurement you want, and so that you can get the rate of flow that you want, right, for your process, right? So yeah, I'm just gonna disconnect this line here, and then put in our what you call our one-way flow. I'm just gonna rotate it 90 degrees, right? Okay, and then connect it to your cylinder, and then connect it to your two-way normally open valve. So if you can double click into your one-way flow valve, one-way flow control valve, you'll see this window, right? So this window, what it's telling us that at the moment, our flow will be at 100%, but we want to reduce that flow for when the cylinder is opening, meaning when it's going back to its retracted position, right? So how you do that is you can just drag on that blue toggle, and then let's just take it to 10. Or when you don't want to do that, you can go to that box at the top there and just write a 10, right? Like that. That is more accurate. And then you control, and then you click OK. Is everybody okay? Okay, where did I lose you? I'll start with which explanation? Which explanation should I start with? Huh? Oh, okay. So the guys here at 4400, they have asked me to restart with the explanation of a one-way flow control valve. So the one-way flow control valve basically is used to regulate the amount of flow in your system. Say you don't want like air at a high pressure, right? You use a one-way flow control, right? Yeah. So so how you adjust that is by double clicking into your one-way flow, and then you'll see under opening level, you'll see a block, a box there. That is where you can put on like however, like the amount that you want. Your what's this? The amount that you want, like going through your system and at a particular rate, right? So for us, for this case, we said we want when our cylinder is closing or allowing the pellets to go through, we want that motion to be as slow as possible. So we just calibrated that to 10, right? 10%, right? So that 10% just means that, say our compressor gives an output of 8 bars or 8, is it pascals? Is it, yeah, the units for pressure, you'll correct me. So yeah, I'm more familiar with bars, right? So if your compressor is giving an output of 10 bars, for example, and we're saying that the opening level should be at 10%, that means that we want the cylinder to now be coming at like is it what is 10% of 10? Is it 1? So 1. So we want our what's this, our cylinder closing at a pressure of 1 bar, right? So that is just what that parameter set means, right? And then you'll just set it at 10, and then you just click OK, and then you can do this. If you just want to see a display of that 10, you can go to on the right there, there's display opening level. You can tick that box and then you can click OK. And then you'll see your 10% there, right? Yeah. So, okay, so we're done with our pneumatic setup, right? Now we have to come to our, what's this? Our electric circuit. So remember, in the problem, they said that this process uses 2 push buttons, and then it uses a logic operation. So we have 2 types of logic operations. We have, I don't think I have time to draw because I can see time is running. So we have the OR logic, OR gate. Some might know it as OR logic or gate. And then we have the AND gate. So what the OR logic means is that, say you have 2 push buttons. What the OR logic means is that you can have one controlling the system or the other controlling the system, right? Or you can have 2 of them controlling the system. But with an AND gate, you have to have 2 of the components controlling the system. One cannot work without the other being on. Yeah. So yeah, I think, yeah, with that explanation, I think you can get the gist, right? So for this case, they're saying that once we press the push button, our cylinder should go back to its retracted position. And then once you click the other push button, the cylinder should close. I mean, it should go to the extended position, which is the initial position in this context, right? So for our case, we're gonna use an OR gate, right? So I'll be more clear in a test that use an OR function or an AND function. I heard someone? Oh, it's good. Okay. So let us go back to our model. So for as the problem mentioned, this is indirect actuation, right? So we can keep our relay there, and then we can keep our valve solenoid there, and then we can keep our changeover there, and then we can keep our push button. But they're saying, for this case, we're using 2 push buttons. So we have to put 2 push buttons in parallel. So you can think of an OR function or OR gate as a parallel circuit. Remember, with a parallel circuit, if you cut off flow on one end, flow will go to the other end. But with a series circuit, if you cut off a section of your circuit, there will not be any movement of either current or voltage or whatever. My electricity is a bit rusty, but yeah, you get the gist, right? So we have to connect our electric circuit in a parallel circuit, right? So we're gonna put on another push button. So you go under switches, you'll go to manually and click the very same push button, or you could have just copied and pasted that one, right? So we're gonna call this PB2, push button 2. And then we click OK. And then there we have our push button 2. And then we connect it in parallel. So, okay, we're going to connect 3 to the 24 volt. And then we're going to connect the 4 to in between the push button and the relay as such, right? And then you have established your OR gate or your OR function, right? And then we are ready to simulate, right? So as I said, once we click play, you'll see that your cylinder will be in the extended position, which is its initial position for this context, right? So let me just click play. And you can see that without me clicking any push button, your cylinder is already in the extended position, right? Now, the problem is saying once we press the push button, the cylinder should go back to its what you call, it should go back to the rear end position or retracted position. So if you can press the push button, okay, it's not going back. It's not going back. Let us see what we did wrong. Oh, okay. I see where we did wrong. We didn't define our two-way valve solenoid, right? So we do the same as we did with the 5 two-way solenoid. So if you can go at the beginning of your if you can go at the beginning of your 3 two-way valve, you'll see a circle, and then it'll be green, and then you double click onto it, and then you label it according to how you labeled your solenoid valve, right? So you name it Q0, and then you click OK. Okay, and then now our simulation should run successfully. So if you click play, it'll automatically extend, and then should you press a push button, it'll go back, right? And then if you release, it'll go forward. If you push this push button, it'll go back, and then it'll also do the same function, right? And then by that, you would have answered your your question, right? So yeah, I hope everyone is fine. Is everybody fine? Is everybody fine? Oh, someone is saying capiche. No, we're not done. We're not done. We are about to do the last exercise for the day, right? So yeah. Yeah, so I'm just gonna go straight to the next exercise. Do not delete all your components for now. But yeah, before that, I just wanted us to appreciate that one-way control valve that we put in, right? So say, okay, let's push the push button again and see something. So if you can see, the speed at which the cylinder is going back and the speed at which it's opening, it's not the same. When it's going forward, it's fast. But like when you press the push button, it's going back at a slow rate, right? We can even take it to 1%. If you can take it to 1%, I think you'll also see how slow it goes back. So we just took it to 1%, and then let us press the push button. Okay. I can see that we swapped them, right? So it's not doing what I wanted to do. So let me just stop and then just rotate. Let me just rotate our one-way flow control valve. We didn't really do, it's just a minor mistake, right? So yeah, I just rotated it so that it can be in the opposite direction, right? So the directions kind of matter in a way. So yeah, if we can just press play. Okay, it's giving us an error, superimposed lines. This just means I have to fix my connections, right? Let me just see. Okay, so let me just reconnect again. So now we put like the one-way flow control valve at 1%, right? So let us click play. So as you can see, going forward, it's very fast. But like if it's gonna come back via its spring return, okay, it's not performing its function. Let me see something. Okay, I think we were okay the way we did it. Let me just delete this and delete this. Okay, let me just connect again. Okay. Okay, so I think for this application, since it's not a double acting cylinder, you're not gonna be able to appreciate the one-way flow control valve properly. So we will see it in action properly when using a double acting cylinder, right? Because okay, it is performing a function, but like the opposite of what we want. So when it's like closing, it's closing at a slow rate, right? Let me just restart it. When it's closing, it's very slow. But like we wanted it like when we are pressing our push button to go back in a slow motion, right? So yeah, I'm aware now that like you'll see this better when using a double acting cylinder, right? But yeah, otherwise we answered our question correctly, right? So I'm just gonna stop that, and then I'm just gonna delete our one-way flow control valve, right? So lastly, let me just close this. So exercise 5. So this is the last one, guys, and then we'll be done for the day, right? So exercise 5, diverting packages, right? So you'll be familiar with the setup and function of a double acting cylinder, and then you'll be familiar with the setup and function of a double solenoid valve. So that is also key. So for this case, we're using a double solenoid valve, right? So description of the problem. Packages will be diverted from one conveyor to another by means of a diverter, right? Further, the diverting gate is advanced when one of the push button is activated and the package is transferred. Can I have your attention, guys, for just, I need 5 minutes of your time, then we'll be out of here. So the package is transferred and transported further. The diverting gate is returned to its initial position when the second push button is activated. So again, in this regard, we'll be having 2 push buttons, right? But for this case, you're not told of any logic operations. You're not told of an AND or operation, right? So a double acting cylinder will be used. The cylinder will be controlled indirectly by means of a push button. In the event of an electrical power failure, the cylinder's piston rod should remain in the current end position. So just bear in mind with one thing. For your test, I'll never test you on direct actuation. It will always be indirect actuation. So just make sure you are familiar with that, you know it, and you master it, right? So going to our simulation, we'll just delete a few components there. So for this application, we do not need a single acting cylinder. We do not need a 3-2-way valve, but we'll need an air service unit and a compressor, right? So let us put on our double acting cylinder, right? And then let us put on a 5-2-way. It's called a it's called a, what's this? A double solenoid valve. So we'll be using a 5-2-way double solenoid valve, right? 5-2-way double solenoid valve. So under your frequently used way valves, you'll go to solenoid operated, and then it's the what's this? It's the 5th option there, right? 5-2-way solenoid impulse valve, and then you'll put it on to your, and it's a normally closed one, right? You'll put it onto your workspace there, right? And then because I said we can appreciate the one-way flow control valve better on a double acting cylinder, we'll just introduce that one-way flow control valve so that you can actually see the change in speeds, the forward speed and the backward speed, right? So we'll just put one of that. It's we'll put it for when the cylinder is going back, right? Then just can just rotate that 180. Actually, it's not 180. It should have been 90. So yeah, but yeah, just corrected that by rotating it to 70. So it should be in this position, and then we can connect our 4 to the inlet port there, and then we can connect our 2 to there, and then we connect our other end of the one-way flow control valve to that end of the cylinder. So if you can double click, let's set it at 5. I know it's shy. Can I please have your attention for just 5 minutes? Then we'll be out of here, right? So how did we know which is the double solenoid valve? Okay, I'm gonna explain that shortly. So we're now just setting our one-way flow control valve. So we want our cylinder, when it's coming back to this initial position, to come back in a slow forward motion, right? I know it's Friday. I know. I also want to be out of here, guys. But since we missed class last week, we just have to push some work, right? I know it's your time, and I'm just asking kindly for your attention. I know it's Friday. So yeah, if we can set the opening level to 5 and then click OK, then let us just also display it, right? 5 there, sharp. Now, the student Ashanti asked, how did we know which is the double solenoid valve? So how you know that is by having two of these. I wish I had a drawing thing. So if you can see your component, it has two. What's this? It has two like circles at the beginning and at the end, and then also it has that as this those horizontal lines at the top there. So okay, just observe my. Can you observe my cursor, right? So you let me just put on one that is not double solenoid, right? So this one, right? It's a single solenoid. How? It's that this portion in the beginning is not like duplicated on this other side. So, but this one, it's the same this side, and this the same this side. I don't really have it. That's the best way I can explain it, right? But yeah, so that's how you see that it's a double solenoid valve, right? A double solenoid valve. This means that you'll be using two solenoid valves to communicate with your 5-2-way valve, right? But as we move along, you'll get to see why it's called a double solenoid valve. So let me just quickly connect. Eta. Okay, okay, no problem. Sharp. Guys, are you having a session after this? You're having a lab. At what time? 12:30. Guys, hey, this guy. Huh? 12:15. Okay. Okay. I guess we'll pick it up. We'll continue from here in the next session. So yeah, guys, thank you. Thank you for your attention. I think it was a productive session. See you again next week. Thursday. Cheers.